Hello everyone, I am going to show you some of the solutions for the arithmetic and geometric sequences review. So for the first section, we're determining if the sequence is arithmetic, find the common difference, the term named, and the simplified explicit formula. So let's look at number 1. So to find out if it's arithmetic, we'll take -9 minus -3, which is -6, -27 minus -9, which is -18. So this one is not arithmetic because you don't add the same thing or subtract the same thing to get the next number. So you don't have a common difference, you have, I guess, uncommon differences. Looking at number 2, let's try this one. So -38 minus -35 is -3. -41 minus -38 is -3. -44 minus -41 is also -3. In other words, to get to the next term, you'll subtract 3. So yes, it's arithmetic. And our D, our common difference, is -3. So first we'll find the explicit formula. So if we look here, our first term, a sub 1 equals -35. So then our explicit formula is a sub n equals, you start with -35 and then minus 3 times n minus 1. So this is fine, but we're asked for the simplified explicit formula. So now we'll do a little bit of algebra. -35 minus 3n, and then -3 times -1 is a positive 3. So we end up with a sub n equals -3n, and then -35 plus 3 is -32. So there's our explicit formula, and now we need to find the 20th term. So a sub 20, we just plug in 20 for n. So -3 times 20 minus 32 is -60 minus 32, which is -92. Next section, still arithmetic, find common difference, and now we're looking for the recursive formula. So let's look at number 5. So -9 minus -12 is 3. -6 minus -9 is 3. -3 minus -9 is 3. So D, or our common difference, is 3. And once again, you can also just look at this as you're adding 3 to get from term to term. So -12 plus 3 is -9, -9 plus 3 is -6, etc. So for the recursive formula, first thing we need is our first term, and you just look at the list. So a sub 1, or our first term, is -12. And then recursively, to get a sub n, you'll take the prior term, whatever it is, a sub n minus 1, and then you'll add 3. So that's how we will write our recursive formula. All this means is if you're anywhere in the formula, let's say we look at -6, to get to the next one, you'll add 3. Next section, we'll determine if the sequence is geometric, and then we'll find all that stuff. So first, let's see, -6 divided by 3 is -2. 12 divided by 6 is -2. -24 divided by 12, no, this doesn't really point to 12, that's okay, is -2. So r equals -2, and yes, it is geometric. So these have A's, the computer program just puts everything as A, but I would call that G9, but don't get confused by it, we're still looking geometric. So then our explicit formula, G sub n equals, well, our first term, G sub 1, is 3. So we're looking in the list at the first one. So we have 3 times our common ratio, -2 to the n minus 1. And there's no simplifying we can do, unlike with arithmetic sequences. Now let's find the 9th term. G sub 9, we'll plug in 9 for n. 3 times -2 to the 9 minus 1, which is 3 times -2 to the 8th. Let's see, -2 to the 8th is 256. times 3 is 768. Let's look at number 12. So negative 25 divided by negative 10 is 2.5. Negative 40 divided by negative 25 is actually 1.6. So this sequence is not geometric. For the last section, we're dealing with recursive formulas for geometric sequences. So let's look at 13. So negative 12 divided by negative 4 is 3. Negative 36 divided by negative 12 is 3. Negative 108 divided by negative 36 is 3. So yes, it's geometric, and r equals 3. We're going recursive. So the first thing we need is the first term. So g sub 1 is, again, we just look at the list first thing, negative 4. G sub n, you take your previous term and multiply it by our r, which is 3. Again, if you're looking to get, the next term in this sequence here, you would take negative 108, which would be our prior term, and multiply it by 3. That's how that works.